OPAMP means operational amplifier. You can find this video interesting if you study something related to circuits, to electronics, or perhaps engineering. My partner and I study bioengineering, and this video is for the assignment of electronics 1. My partner is and my name is Juliet Lizarazo. In this video, we're going to show you 3 examples of operational amplifiers, and we're going to show you some examples of them and how they work and what they do. Well, for introduction, we have what is an OPAMP. OPAMP means operational amplifier. An operational amplifier is a DC coupled electronic voltage amplifier with a differential input, a single-ended output, and an extremely high gain. Its name comes from its original use of performing mathematical operations in analog computers. What is their function? As I said before, its main function is to amplify signals of voltage to bigger ones. And it can be helpful for many circuits because you can use them to amplify a signal, compare voltage, realize arithmetic operations, and filter signals.
The first amplifier is an inverter. What an OPAMP inverter does is increase the signal and change its polarity. This means that if the signal that is coming is in positive, the signal that will come out will be negative.
Okay, this operational amplifier is called inverter because, as you can see, we have all sorts of voltage in this side with this resistor, and it's coming in for the circuit in his negative side. And we're gonna have the ground in the positive side. Okay, so as my friend said, the equation for its gain is A, which means gain, equal to V out, which is the voltage that's coming out of this amplifier, divided in V in, which is the voltage that's coming in the amplifier. We only have to replace in this equation, and as you can see, we have a minus sign at the beginning of the answer. So it's going to be R2 divided in R1. So if we have any other values on this side, we only have to put these values there. For example, we have this configuration. We have these values for the resistors. So V out is going to be minus R2 divided in R1 multiplied by Vn. As I said before, Vn is our source. So if we replace, it's going to be minus 9k ohms divided in 7k ohms multiplied by 4 volts. V out is going to be minus 1.29 multiplied by 4 volts, and our final answer is going to be 5.143 volts.
And the second amplifier is an subtract. For this configuration, its main function is to subtract 2 input signals and amplify in the output.
Okay, as you can see, we have the signals of voltage getting into this amplifier by for the 2 channels. Okay, so we have the negative channel and the positive channel, and we have the ground here. So we only have to replace, and perhaps if you looking at this presentation, R2 here is going to be the same value that R2 right there, and R1, these one resistors, going to have the same value. So its equation is going to be A, which means gain, equal to V out divided in Vn. We only have to replace Vn because, as I said, my partner, Vn is going to be the subtract of Vn1 minus Vn2. So we only have to accommodate like this equation, and it's going to be R2 over divided in R1 multiplied by Vn1 minus Vn2. As an example of this configuration, we have this. So as I said before, we only have to replace the values. So V out is going to be 3k ohms over divided in 10k ohms multiplied by 8 volts minus 10 volts. V out is going to be 0.3 multiplied by minus 2, and the final V out is going to be minus 0.6 volts.
And finally, in an inverting summing amplifier. It is a configuration that, as its name characterizes, has two or more voltage connected to the inverted input of the amplifier, and the non-inverting input is connected to ground. With this configuration, we will obtain the inverse voltage of the sum of the amplifier input voltage.
Okay, as my friend said before, with this configuration we're gonna have a negative V out. And we have to say that the signal that's coming in is negative. With this negative, the answer will be positive. So, as my friend said, we can put as many sources as we want because it is inverted summing. The equation for this amplifier, we're not gonna show you the equation for the gain, but we're gonna show you the equation for the V out. This is gonna be minus Rx, which is this resistor, divided in R1. It's like we turn off the other sources and we only calculate the V out in just one channel. So at the end, we're gonna sum all the sources and we're gonna have the V out, the final V out. So we only have to replace in the place of the equation. Well, an example for this amplifier, we have this graphic. As you can see, we have three sources. The value of the first source is 4 volts, the second is 5 volts, and the third is 7 volts. So we only have to replace in this equation. So the first equation says V out is going to be minus Rx divided in R1 multiplied by V1. As I said before, it's like we turn off the other sources and we only calculate it there, so this channel. Okay, so we're going to replace and, well, we're going to do that, like turn off the other sources in every parenthesis. Okay, so in the first parenthesis is like we turn off these sources. The second parenthesis is like we turn off these sources. And the third parenthesis is like we turn off these sources. Okay, so the V out is going to be minus 6k ohms divided in 3k ohms multiplied by 4 volts plus 6k ohms divided in 3k ohms multiplied by 5 volts. And the third source is going to be plus 6k ohms divided in 9k ohms multiplied by 7 volts. So if we do that operation, we will have minus 0.5 multiplied by 4 volts plus 0.5 multiplied by 5 volts and plus 0.66667 ohms multiplied by 7 volts. If we if we do the sums, we will have V out equal to minus 2 volts plus 2.5 volts and plus 4.667 volts. So the final V out is going to be minus 9.1667 volts. So I hope you find this video interesting and it will help you to do your assignments, and we're happy to teach you this kind of configuration for OPAMPs. Okay, we forgot to say something about the OPAMP, so my partner is going to explain that. Thank you.
Feeding of op-amps. Every op-amp must be powered so that it can amplify the signal is receiving. This power supply normally comes from two sources of connected from the positive terminal and another from the negative terminal. As we can see in the image, this amplifier is receiving two power supplies which are called plus VCC of the positive input and minus VSS for the negative input. What does this mean? Because op-amps can amplify signals using the power supply, they are also limited by this. Therefore, the output signal of or output voltage cannot be greater than the voltage being used as power supply. For example, the gain of this amplifier will be 20 in this case, so its output will have a value of minus 20 volts, but when fed with as minus VSS voltage of minus 15 volts, this output will take a value close to minus 15 volts.